Flat iron on for a reason.
Yeah.
All right, hey guys, we'll be starting here in just a couple minutes. We're going to be going over the review for the tests that's coming on Thursday. So you can find that in your module for this week if you want to open that up and work along with me, or if not, I'd have some paper and pencil out to take some notes. All right. Let's get started here. Okay. So just a little bit of housekeeping here. So if we go to, this is our student view here, with our modules. For this week, all I posted in this week is the study guide. The exam is going to be coming on Thursday at 8 a.m. It'll be posted. There'll be several different versions that I'm going to assign to randomly to different people. So you'll have Thursday and Friday. The weekend, if you want to, you don't have to work it on the weekend. And Monday, it's going to look very similar to the study guide. So if you are having trouble today understanding some of the things on the study guide, you can definitely come to office hours and ask questions and get a better clarification on some of these problems. But if you can handle the study guide, you'll definitely be able to handle the tests. The study guide is actually a little bit trickier than the test. So anyway, so let's get started on this. So there's about 12 questions on this, so we will probably just about have enough time to get through everything. Okay, let me go full screen here. All right, so number one, I'm given some points here. First thing I want to do, I think on your test you don't have to worry about this, you'll actually have axes, but these graphs don't have axes, so I'm going to go ahead and just make some vertical and horizontal axes here so I can place my point. Okay. So then I have my 2 points. We have H at 2, 7. So I'll go to 2, 1, 2, 3, 4, 5, 6, 7. That's H. And J is at negative 8, 9. 2, 4, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's J. Okay. All right. So, and that's JH. So I want to find the midpoint of that. Well, I could do it graphically, but to be perfectly honest, I don't really need this whole graph. This might be easier just to check my work later. But if we use the midpoint formula where we add our two x's together and divide by 2, so we would take 2 plus negative 8 and divide by 2, so 2 plus negative 8 is negative 6, and divide by 2 gives us negative 3. So that's our x coordinate of our midpoints. We're halfway there. Okay. Same thing with our y's. 7 plus 9 divided by 2. So 7 plus 9 equals 16. Divided by 2 gives us 8. So our coordinates are negative 3 and 8. And if I plot that, negative 3, 2, 4, 6, 8. That's right about there. I didn't draw my blue line too straight, but that's right in the middle. So that's my answer. Okay. So you can do it graphically. You can see that this point is halfway up the vertical. It's halfway along the horizontal. Or you can use the midpoint formula. All right. So this one, number 2, is a little bit different. Notice the first one, we were looking for the midpoint. This time, we're given a midpoint. We're asked to find the other endpoint. So let's just start the same way. We gotta let's draw out our axes. Okay. We need to place our points. So we got -3, -4, or sorry, 3, -4. So 3, -4. That's L. And then our midpoint, which they'd say is M, is at 5, 6. So 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5, 6. And that's our midpoint. All right. Well, I'm kind of going to run into a problem here because I'm going to run out of room here. My segment is going to keep on going, something like that. And it's going to be my other endpoint is going to be somewhere off the end. That's where K is going to be, somewhere up here. Okay. So for this one, I'm going to have to almost exclusively look at the coordinates. We're going to have to solve it that way. So the way that we find it is we look at the X coordinates. Look at L is our starting point and M is halfway there. So we got to figure out what did we do to get from 2 to 5. And the answer is we added 2. Okay. So if that gives me halfway there, I want to keep on going all the way there. So I go from my midpoint, I need to just add another 2, which is going to give me 7. Oops, that's a point. Back. Do the same thing with the Y's. I start with -4. I'm going to +6. So from -4 to +6, well, that is an increase of 10. So I've got to increase again by 10. Plus 10, which would give me 16. So there's my answer. Definitely off my grid here. Though I guess I could have redrew my axes. Make them lower, give me more room. That's okay. $7.16. Okay. So those are the types of questions you might see with midpoint. Okay, you're either going to ask to find the midpoint, or they're going to be given the midpoint. You're going to be asked to find the other endpoint. But if if you needed, like, you missed part of this or you came in late, I'm recording this, so we'll have this posted. This video posted shortly. Okay. All right. Number 3, calculate the length of a segment. Well, let's graph this. This is going to be a lot easier if we graph this. That was terrible. A little better. Okay. Yeah, 2 points. -2, +1. That's A. B is at 4, -8. All right. I'm going to draw this segment. Too bad. Okay. Find distance. We're going to use Pythagorean theorem. By the way, some of you attempted to solve lesson 3, the plane trip problem, using distance formula. I'm okay if you know how to use it and you do it correctly. The problem is that everybody who tried to use distance formula got it wrong. And the reason you got it wrong is that there's a lot of places in distance formula to mess up, which I'll explain later. So let's let's solve it using Pythagorean theorem first. So we need to find our vertical and horizontal displacements first. And what that does, that creates a nice little right triangle for us. Okay. And now we can use Pythagorean theorem, which is c squared equals a squared plus b squared. Okay. And we're looking for c. That's our that's our hypotenuse. That's the diagonal length that we're looking for. A and B are pretty easy. We can just count the units. 1, 2, 3, 4, 5, 6. So that's 6 for the horizontal. And 1, 2, 3, 4, 5, 6, 7, 8, 9 for the vertical. So when I plug those in, and actually, one thing we can do here is we can actually, oh, that was weird. Well, we'll get to that in a moment. Okay, so we'll plug in 6 for A and 9 for B. And then we can solve from there. So 6 squared is just 6 times 6, so that's 36. Plus 9, 9 squared is 81. Okay. Oh, and I think that is 87. I think that's 117, but it might be too early in the morning to trust my brain's working. So let's see, 36 plus 81 is 117. Okay. And the last thing we need to do is square root. So we get square root of 117. And here's where we need a calculator. So 17 square root. We get approximately 10.82. So we looked at 2 decimal places, 81, but then the next number is a 5 or higher, so that's going to round up to 10.82. Okay. Okay. So one thing I'll show you real quick. Why does distance formula not not the best. So, and actually, it's better to use Pythagorean anyway because distance formula is based on Pythagorean theorem. So, distance formula, those of you looked it up or were taught that in algebra, equals square root x1 minus x2 squared plus y1 minus y2 quantity squared. It's this big, ugly looking thing. You got x's and x1s and y1s and x2s and ys2s. And what you have to do is you have to plug in the appropriate numbers. Okay, so if you mess up, so here's my x1, here's my x2. If I mix those up, well, that wouldn't be too much of a problem, but we have y1, which is that one, and that's y2. So already there's a lot of stuff to get mixed up in this formula. And here's the other problem. If you're not good with adding and subtracting positive and negative numbers, if you're not really strong with that, you'll mess up. And that's what people are messing up on their homework when they try to use distance formula. So I would try and avoid that as much as possible. Like, for example, like if I plug that in, I'd have -2 minus 4. Okay. Well, if I just messed this up and I did like, -2 minus 4, and I said, oh, that's -2. Okay, no, that's not. It's actually -6. So that's one place we could have messed up. Okay. And then over here, we have y1, so that would be 1 minus -8. Okay. Maybe I messed it up. I don't remember what minus and negative means. That means actually plus. So so I go 1 minus 8. Oh, that's the -7. No, it's not. It's actually 9. Okay. Well, what do you notice? This 6 matches this 6. And this 9 matches that 9. So distance formula is actually based on the Pythagorean theorem. Okay, so that's where they actually get the formula from. It's just a lot. It's a Pythagorean theorem with extra steps, basically. So you're doing all this extra work to essentially do the same thing mathematically. So there's a lot of places where you can mess up if you're not good with your positive and negatives. So I suggest using Pythagorean theorem more than distance formula. Okay, so if that's your thing and you are, good with that, it'll come out and be the same answer. We keep going here. -6 squared. It's going to be -6 times -6, which would be positive 36 plus 81, which is going to still come out to be a square root of 117. So both ways it works, but I like my way better, or not my way, the Pythagorean theorem way. All right, let's do another one real quickly. So go ahead and plot our points. 3, 6. 3, 1, 2, 3, 1, 2, 3. That's A. B's at 7, 1, 2, 3, 4, 6, 7, -2. Okay. Let's get our vertical and horizontal distances. 1, 2, 3, 4, 5, 6, 7, 8. And our horizontal distance is 4. Pythagorean theorem. 4 squared plus 8 squared. The other thing good about Pythagorean theorem, it doesn't matter if I mix these two numbers up, I'm still going to get the right answer. So there's a lot less to mess up. Oops. Oh. So 4 squared is 16. 8 squared is 64. Add those together, that should be 80. So then I square root. So C equals square root of 80. All right, so then I need my calculator. So 8.94. Yep, we're going to third decimal. We don't round down, round up. So 8.94. Okay. By the way, in just about every unit, we're going to be having to do this. Whenever we have coordinate grid, we're usually a lot of the time we're going to have to be finding distance length. So that's going to be something in the future we're going to be using a lot. So you're going to have to keep doing this and keep getting good at this. And after a while, you'll start picking up a little bit of the shortcuts, and you'll be able to skip some steps, and you'll get going on this a lot faster. All right, so that's distance. Then we'll have some questions on vocabulary, so recognizing symbols. I'll keep doing that. So first thing we gotta look at, what is this first guy right here, this AB with a little bar above it? Well, that's a line segment, so that means it stops. So I'm gonna draw that first. A and B there, though I could have switched those. The order doesn't really matter for line segments, only matters for rays. So this symbol right here, that means parallel. So the next thing I have to draw is going to be parallel to that AB, which is this guy, which is line CD. So I'm going to try and draw as close as possible to parallel. So there's C and D. I can mix those up. It doesn't really matter because those are, or doesn't matter in lines either. Now, the only thing I have to do, even though I drew that as best as I could to make it look parallel, to be absolutely 100% accurate, I've got to put the little parallel arrows on my line. Okay, some people like to put 1, some people like to double up, put 2. That's your personal choice. So, okay, all right. So that's the correct sketch for number 5. Number 6. So same thing. Let's start with this guy. That is a ray. So ray, the order does matter. We have to start at the first point, so that's A, and then continue on past B. Okay. All right. And we have this symbol here that kind of looks like an upside down T. That's perpendicular. So the next thing that we draw has to be perpendicular to that. So which is line CD. I'll draw that. Perpendiculars intersect like that. And they have to make a right angle. That's how we indicate that we are perpendicular. So right at the intersection, we're going to put a little box there. Now it tells us we have a right angle, and those are perpendicular lines. Okay. Moving on. Okay. So we have this problem here. So what makes this one different is that we don't have a picture. So that's the first thing we're going to draw. We have C is in between D and E. So I want to actually draw that. Oops. Do a little better than that. So here's D, here's E, and somewhere in the middle, we don't know if it's exactly in the middle, there's C. Okay. Now we're going to do segment addition. So we have 3 different parts here. So this first part, DC, that's this section. That's 2x plus 30. And we have CE, so over here, that's 3x plus 25. And then the entire thing, D to E is 65. Okay. And they want us to find both DC and CE. Well, we're going to use segment addition because we have 2 parts and the whole here. So that's how I'm going to set up. I'm going to do 2x plus 30 plus my 3x plus 25 equals the entire thing. Okay. All right. So now I got to collect like terms. Now, when I'm collecting like terms, so one tiny little algebra mistake I saw, if we're collecting things on the same side of the equal side, we don't have to do a plus or minus, you know, x's or plus or minus anything. We just go ahead and add the things together if they're on the same side of the equal sign. So like this 2x and this 3x, they're both on the same side of the equal sign. We can already put them together. That's just going to be 5x. Okay. We have a 30 and a 25. They're both on the same side of the equal sign, so you can go ahead and add them. Get 55. And then nothing's over here with that 65, so they stay the same. Okay. So now when I want to collect my constants, I got 55 over on one side of the equal sign and 65 on the other. So that means I do have to subtract. Okay, since it's positive, so I do have to subtract the 55 there. So now I've got 5x equal to 10. Last step, divide by 5, and x equals 2. Okay, so this is not my answer though. They want D, C, and C. It means I have to plug that x equals 2 back into these 2 parts, which is a good idea anyway, because we can mess things up. If you guys watched one of my videos, I made a big mistake on one of them, but I caught it by plugging it back in. So I plug that in here to DC. Well, we'll get, bring it over here. So we'll do it up here. 2 times 2 plus 30. So 2 times 2 is 4. plus 30 gives us 34. So that's DC. Okay. That's 34. Do the same thing. Plug it in for CE. So we'd have 3 times 2 plus 25. Well, that's 6 plus 25, which equals 31. Okay. And we'll just do a quick check there. What do we get when we add 34 plus 31? Well, do we get 65? Yes, we do. That means we are correct on our answers, and we can rest easy. We're going to get 100% on that problem. All right. Number 8. Got to draw this picture here. So I've got M is the midpoint of AB. Here's AB. There's M, it's the midpoint, so those are equal. So we have AM is 3x plus 4, and MB is x plus 44, and they want us to find the length of everything. They want to find both sections and the length of the entire thing. So if this is a midpoint, that's the key word here. Okay, that means that these are equal. So we set them equal to each other. So 3x plus 4 equals x plus 44. Now there's no common terms to collect on either side. So that means that we do actually have to subtract or add accordingly. So there's lots of choices to start. I like to move the smaller x's to first. So I like to subtract the smaller x's, keep things positive. So I'm going to do that, subtract x both sides. So now I've got 2x plus 4 equals 44. So I have to subtract 4 from both sides. Oops. You get 2x equal to 40. Divide by 2. And we get x equal to 20, but that's not our answer. We have to plug that back in to both parts. So plug that side, we get 3 times 20 plus 4. So that's going to be 60 plus 4. So that's going to be 64 for AM. Same thing for MB. So we have 20 plus 44, which equals 64 again. So we know we did that right because those two have to be the same. And then if I want the entire thing, well, I'll just add those two together. That would give me 128. So okay. We'll be able to get most of this. Let's see if we can finish. All right. Again, this is only tricky because we don't have the picture. We have to kind of read and figure that out. So Mr. C constructed angle ABC. So let's do that. So that means that B has to be in the middle here. That's our vertex. It doesn't matter which side A or C is on. I could flip-flop those, but here's angle ABC. He then constructed angle bisector BD, that's a ray. Okay. And he used a protractor, and he found that ABD, so that's this guy right here, is 22 degrees. So find determine measure of DBC. Well, the key word here is bisector. So if BD bisects ABC, that means that this is also 22 degrees. So that one's pretty easy. Okay. And then the entire thing, I'll just add the two together. So angle ABC, measure of angle AB, that's what the M stands for, by the way, is the measure of equals 44. Okay, so once you get the picture, it's not too bad. All right, same thing here. Got angle X, Y, Z. So Y has got to be in the middle or at the vertex because it's in the middle. And it doesn't really matter where X and Z, I could flip-flop those, that's okay. There's X, Y, Z. And then we have W in the interior, so W is somewhere, there's W. And then what that's going to do is that's going to create a couple other angles. So I can sketch that out. So then I have XYW, and I've got ZYW as well. So now we got to just kind of label these accordingly. So I'm going to use so for XYZ, angle XYZ, that's the entire length. That's 11x plus 14, okay? XYW, that's this guy, that is 5x plus 20. And then ZYW, which is this guy, ZYW, is x plus 34. Okay. So it's just like the segment addition. You take the two smaller parts, add it up to the entire thing. So we got 5x plus 20 plus x plus 34 equals 11x plus 14. Okay. All right, we're going to like terms. So I've got like terms on the same side of the equal sign. So I don't subtract or do anything like that. I just put them together. So 5x and x give me 6x. 20 and 34 give me 54. Then I'm left over with 11x plus 14. So now I do have x's and things that are on different sides of the equal sign. So now I do have to actually subtract from both sides. So we'll go ahead and subtract 6x. So then we get 54 equals 5x plus 14. Going to subtract 14. That's going to be 40 equals 5x. Divide by 5. And we get 8 equals x. Okay. That's our answer for x. Then they want us to plug it into x, y, z. So we plug that in here. So 11 times 8 plus 14. Now that's 88 plus 14. You choose, that'd be 102. Now, ordinarily, if we weren't short on time, I'd plug this x equals 8 into the other two and do a check. Make sure that everything ended up to 102, but we're running out of time here. I want to get at least question number 11 done. I may not get to number 12, but it's just like number 11. Okay. Coordinates. So we got to very quickly here put a grid down. Okay. We got -3, -6 for A. 2, 3, 6. And B is at 3, 6. 3, 1, 2, 3, 1, 2, 3. There is B. Okay. And we want to divide apart 1/3. So this is a partition problem. So first thing I want to do is I want to divide or find out my horizontal displacement. So I'm going from -3 to +3. So if I'm just looking at this section here, that length is 6. 1, 2, 3, 4, 5, 6. And I'm dividing it into thirds, which means I'm going to partition that every 2 units. So there's one partition, there's another partition, okay? And I'm going from A to B, so that means I'm going left to right. So that's 1/3, and that's 2/3. So, and I'm looking for 1/3 of the way. So this is the division point. So my x coordinate is going to be -1. Okay. Do the same thing on my vertical. I mark the top and the bottom of my displacement here. Count out the entire length of that. So that's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 12 divided into thirds is 4. So I got to mark out every 4. 1, 2, 3, 4. That's one division. 1, 2, 3, 4. That's another. Starting at the bottom going up, that's 1/3. And that's 2/3. Well, I'm looking for the 1/3. So there's my y coordinate is at -2. And if I actually plot that point, if my pen will work, -1, -2 is right here on our line, and that is our point. That's the point we're looking for. So that's point C they want. So that's all the time I have. There's one more problem. You can stay if you want. I'll finish up this last problem. The rest of you are free to go. So
Thank you, sir.
you're welcome.
Thank you.
Thank you.
Okay, those of you staying, I'll finish up this last one. So this one's nice to actually have the axes and the points. That saves me a little bit of time. Okay, A is at -6, -4, so that's A. B is at -2, 8. There's B. Okay, same sort of thing. We need to find our horizontal and vertical displacement. So starting to the left, moving here to the right, that's our horizontal displacement. That's 4. Okay, and we're dividing it into 4, so that's pretty easy. Okay, 4 divided by 4 is 1, so this is already partitioned for us with our units. And we want to go 5/4 of the way. So let me zoom in any further. From A to B. So the only part that's a little tricky. So that's 1/4. Actually, let me zoom in a little further. That's 2/4, 3/4, 4/4 would get me all the way there, but then we need to keep on going outside of our line. That would be 5/4, which is -1 for our x coordinate. Okay. Same thing for our vertical displacement. So our total distance here, if we counted up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 12 divided into fourths is 3, so we would divide this every 3. 2, 3, 1, 2, 3, 1, 2, 3. Again, we'd start at the bottom because we're going from A to B. That would be 1/4. That'd be 2/4. That would be 3/4 of the way. That'd be 4/4 of the way, but then we need to continue on. We need another 3 units up here. That would be 5/4 of the way, so that would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would be our coordinate. So -1 and 11. So right there, which if we extended our line out, would be our point. Okay. Call that point C. And that's our answer. All right, so that's all I got. Is there any questions? Cool, I'll let the rest of you guys go. That's the end of our meeting. Take a look for our test on Thursday.